Alright, so this video is going to be about light. When I talk about light, I'm talking about the visible light. That's that small part of the EM spectrum that we learned about last video. Just that teeny part that you can see. That's the light I'm talking about. And remember, it's comprised of all of the colors: red, orange, yellow, green, blue, purple, and violet. And when they all shine together, it looks like white, but it really is all of those colors together. So how does this light interact with matter? It can do two things. It can transmit the light, which means that the light goes through the object. If it does this, it does it in one of two ways. It's either the object is transparent, which means it's clear, it's completely see-through. Think of like a water bottle. Or it's translucent, it's foggy. The light goes through it, but the picture doesn't, basically. Think of like the white milk cartons, not the yellow ones, but the white ones that milk comes in, the big gallon jugs. That's a really good example of a translucent object. If it doesn't transmit the light, if the light doesn't go through the object, then it can be absorbed or reflected. If an object absorbs or reflects light, it's considered opaque. Anything that's solid that you can't see through is an opaque object. So if it makes a shadow, again, if you can't see through it, it's opaque. So for example, I'm opaque, my sweater is opaque, the tables are opaque, doors are opaque, mirrors, again, anything that reflects the light is also considered opaque because you cannot see through it. So reflection, this is when the light bounces back. When the light bounces back, it bounces at the exact same angle it hit the object at. So for example, if you were to shine a flashlight at a mirror at a 45-degree angle, that light would come back off of the mirror at that exact same 45-degree angle. Reflection, most objects reflect light. But what happens is, and the reason they don't all appear like a mirror where you can like see your face in my sweater or see your face in my hair, they are reflecting light. The issue is there that most objects reflect light in lots of different directions because they're not smooth. Picture a mirror, picture how it's smooth. There's not a single bump in the surface. If there is a bump in the surface, that part of the mirror, that part of the image is messed up because that light hit it at a different angle, it's bouncing back at a different angle. So because they aren't smooth, the angle hit each part was different. The angle that the light hit each part was different. So the angle of the reflection is different. That's why you can't see your face in it. So the reflection and absorption of light determine the color that that object is. So light, like I said, has all of the colors in it. The color an object appears is the one reflected. All of the others are absorbed. So for example, this red apple absorbs the red light and reflects the orange, yellow, green, blue, and purple light. This green leaf absorbs the green light and reflects the red, orange, yellow, blue, and purple light. So what happens to this light as it interacts with matter? When light passes through matter, it slows down dramatically. That change in speed causes two things to happen. It can change the direction of the light. If the light changes direction, this is called refraction. So reflection, remember, was the exact same angle, the exact same direction. If the direction is changed, that is refraction. So we have reflection, same, refraction, different, okay? So imagine sticking a pencil in a cup of water. When you look at it, it would look like the pencil's broken. We're actually going to do this experiment. Or think about someone standing in a pool. Sometimes their bottom half looks a lot different, bigger or smaller than their top half. Or the ladder in the pool, it may look like the ladder is broken. Those are really good real-life examples of refraction. The other thing it can do is scatter the light in many directions, and this is called scattering. Think of like when you can see the rays of sunshine through a cloud, that's because the light was scattered. Or if you're looking at like a street light at night and you can see like that haze around it, that halo, that's that light was being scattered. Light can do all of these things. It can be absorbed and reflected and refracted and scatter, all of these things at the same time. So most things you see are a combination of all of these things at the same time.